we are going to look at two special types of tangent line. If you are asked to find tangent parallel to the x-axis, then you consider dy dx equal to 0. If tangent line is parallel to the x-axis, then it will be like dy dx is 0 because gradient will be 0. Any line that is parallel to the x-axis has gradient 0. So gradient is actually 0. Then if you have tangent line parallel to the y-axis, you get vertical line. And dy dx will be plus or minus infinity. Vertical line. And vertical line will find that the equation is of the form x equal to x naught. It's like if I give you a line, let's say here is 3, and if I ask you to find equation of this line, parallel to the y-axis. So here is 3, equation of this line will be just x equal to 3. Because any point on this vertical line, the x value is 3. Then if we had a line for the case when tangent is parallel to the x-axis, it's just a horizontal line. Horizontal line, the equation is just y equal to a number y naught. Okay, so let's say here is 4. This line, it means all the y value on the line is 4. Then the equation of the line is just y equal to 4. Let's look at this example. So you have a curve has this equation. First part, you are asked to find dy dx. And then you are asked to find equation of the two tangents which are parallel to the x-axis. And part 3, you are supposed to find equation of normal to the curve C at the point 0, 10. First, you try to find dy dx. So you differentiate. You differentiate y squared will give you 2y dy dx. The 4xy term will give you minus 4x. Keep x, differentiate y will give you dy dx. Keep y, differentiate x give you 1. Differentiate x give you 1, so don't need to write. Differentiate x squared give you 2x, so give you 16x. Differentiate the right hand side constant give you 0. So with that, you can actually make dy dx a subject. Okay, so dy dx, that means you can take out dy dx. You can take out dy dx, right? So it's 2y, so that means it's 2y minus 4x bracket dy dx equal to, then this two term you bring it to the right hand side, so it will be 4y minus 16x. And then to find dy dx, you just divide by 2y minus 4x. So which means the next step is just divide by 2y minus 4x. So you divide by 2y minus 4x. And I just erase this. So I just erase this. So it means dy dx is actually 4y minus 16x over 2y minus 4x. Which you can actually divide by 2 to the numerator and denominator. So you can actually divide by 2. You can take out 2 and divide, so then it becomes 2y minus 8x over y minus 2x. So this will be the answer to dy dx. And next we have to find equation of the two tangent lines which are parallel to the y-axis. If it's parallel to the y-axis, then it will be vertical line. And how to find tangent parallel to the y-axis? Quite often you will find that you have dy dx equal to a fraction. So equal to a fraction. Then if you have vertical tangent, right, means denominator is 0. So you just equate denominator to 0. So which means part 2, right? Part 2 you consider the denominator equals 0 because you want tangent line parallel to y-axis. So denominator 0. So just look at the denominator. So denominator is y minus 2x. So I need to consider y minus 2x equal to 0. So it's same as y equals to 2x. And then like the previous example, you will solve simultaneous equation with the original equation. So original equation is 1, and this equation is 2. So you can substitute equation 2 into equation 1. Then you will have y is 2x, so you have 2x squared minus 4x times 2x plus 8x squared equal to 100. And you will find that with this, right, you have 4x squared minus 8x squared. 4x times 2x is 8x squared, and plus 8x squared is 100. So you cancel out. 8x squared minus 8x squared cancel out. So 4x squared is 100. It means x squared will be 25. Divided by 4. 100 divided by 4 is 25. So x is plus or minus 5. Remember just now we had this. If you have vertical line, the equation is just of the form x equals to x naught. Like what I mentioned here, if x is 3 means the equation of the tangent line is x equal to 3. Yeah? So which means the answer to part 1, there are 2 vertical tangents, 2 tangents parallel to the y-axis, and the equation is x equal to 5 and x equal to minus 5. Next we'll be looking at part 3. Yeah? Part 3 asks you to find equation of normal at the points 0, 10. So that means you sub x as 10, sub x as 0, y as 10. Yeah? So you sub x as 0, you can find dy dx. You want to find equation of normal. To find equation of normal, you must find gradient. So you means you find dy dx at 0, 10. So you sub x as 0, y as 10. So be 2 bracket 10 minus 8 bracket 0 over 10 minus 2 bracket 0. So it's 20 over 10. The part is 0, so don't need to count, right? This part is 0, don't need to count. So 20 over 10 gives 2. So dy dx is 2. So that means normal, if you consider gradient of normal. So if you consider gradient of normal, it will be minus half. So we can look at gradient of normal. It's actually minus 1 over 2. Remember, gradient of tangent times gradient of normal is minus 1. Gradient of tangent line times gradient of normal line is minus 1. So that means gradient of normal will be minus half. So with that you can find equation of normal line. So it will be just y equal to minus half x. You can give in Poinsot form, or you can use the other one as well. So you know gradient of normal is minus half, and then you can write it out. You can write down the answer. So let me show you what to do. So normal line, right, is like this. So we just found the gradient of dy dx is 2, right? So minus 1 over m is minus half, right? That's what we have. So gradient of normal is minus half. It's minus half. So that means you can use this equation. And we are looking at 0, 10, 0, 10. So it should be y minus 10 equal to minus half x minus 0. M is 2. We just found dy dx. dy dx is 2. dy dx is 2. So that means m is 2. And then you just sub inside here. M is sub 2. Or you bear in mind minus 1 over m is minus half. Also can. So that means it will be just y equal to minus half x plus 10. The answer. X minus 0 is x. So answer is minus half x plus 10. So means the answer here will be y equal to minus half x